Hey everyone, and I'm Yeshu. So, the people who don't know me, I'm currently pursuing my final year in computer science and engineering. And in this video, I would be talking, or I would be rather putting upon my thoughts, or I would be describing what is horizontal scaling and what is vertical scaling, and how are those different from each other, and why do we actually need them. So, firstly, let's start with a simple, very basic example. So, suppose you're having a web server which consists of 4 CPU core and 16 GB of RAM, and there we have a client which sends your incoming request, and of course the number of computing resource would have always have a threshold amount. So suppose your server, which is having computing resources as 4 CPU core and 16 GB of RAM, has a threshold of, let's suppose, has a threshold of let's say 3000. So 3000 requests per second, like concurrent requests per second. So client sends 3000 concurrent requests per second. So the server has a threshold amount where it can easily handle all those requests. So 300, 3000, sorry, 3000 requests. And suppose now uh, there is a flash sale, I guess. Suppose there is a sale and the number of concurrent requests increases to 3500, for suppose 3500. So we have a threshold amount that is 3000, and now the concurrent request has exceeded the threshold, which leads to degradation of our performance in computing those resources, and our web application eventually slows down and crashes sometimes. So you understand the problem now. Why do we actually need scaling? So again, scaling, as I said, there are two ways: horizontal scaling and vertical scaling broadly. And what would be the solution? Like, what would be the obvious solution to make this scalable? We could add more computing resources, right? We could add more core, we could add more RAM, so that our server could process, our machine server could process more and more of concurrent requests. So we did so. Initially we were having three, suppose three, so three threshold, and we add more computing resources. So 4 CPU core increases to, let's suppose, 8 core. It could be any times, it could be 5, it could be 6, it could be 7, it could be 100, it could be any number of cores. And 16 GB of RAM was upgraded into X amount, like for suppose I took 32. So our computing resources have been improved. So now the threshold value will also improve because our computing resources have improved. So the number of concurrent requests a server could handle is also improved. So the threshold suppose improves to 4000 per request per second, concurrent request per second, and our server is very happy. Like, clients are happy, server is happy, developers are happy, all everything is going very good. Suppose on a very big sale, again there are, suppose, 8000 8000 requests per second, concurrent requests per second. So at that time, again, our performance would degrade, our servers would crash, and our application would eventually crash, which would decrease our customer engagement and overall performance, and overall how customer thinks about our product. And to make this, again, we could think of adding more and more resources, computing resources. So let's do it. We could add more number of CPU cores, we could add more number of RAM, but there is always a upper bound to adding number of resources. Like, you can add X times number of resources, but there would be always upper bound to a machine that could handle those resources. Suppose you're having a upper bound of 50, suppose 50 GB of RAM, and you add a 75 GB of RAM to your computer, which would, that computer would not able to uh, run or utilize all those RAM. So there is a upper bound to every machine, and so it is so right now here. And to, again, this I mean that this architecture we talked about is basically what vertical scaling describes, adding number of in a single server in a single over machine, adding number of more computing resource so that our incoming request could hand our server could handle incoming requests more effectively. And then, as I said, there would be an upper bound which would always be a case, and to handle that upper bound we could do is something. We could take our this again, we could have a server which suppose initially was one server, and we could have multiple servers, like multiple machines which could handle the incoming requests. So instead of only one machine handling those incoming requests, we could replicate the same application over different machines. It could be for the example, it's right now 3, it could be n, it could be any number of machines, and there could be a load balancer. And if you don't know about load balancer, we would talk about in the next video, but there could be a load balancer which would distribute our incoming client number of client requests to all those available servers which are healthy. So this could easily scale our architecture more, and whenever there would be like a performance is degrading, we could have we could increase vertically it too, but for making it more reliable and more scalable, we could always have replicating those application over different machines, and we could load balance those active running servers. So yeah, that was all from this video, and if you have anything to ask or anything to suggest, the comment section is always welcome. And I hope you like this video, and if anything is unclear or anything is wrong, I would love to hear a feedback from you. And yeah, thank you. This was all for this video, and see you in the next video. Bye bye.